Assalamu alaikum. Today I am going to introduce the course Electric Circuit Analysis. We have a review of this course today. First of all, we are going to discuss the five basic circuit elements. The five basic circuit elements are voltage sources, current sources, resistors, inductors, and capacitors. We are going to study these five elements briefly. The first one is voltage source. A voltage source is a two-terminal circuit element that maintains a voltage across its terminals. The value of the voltage is the defining characteristic of a voltage source. Voltage source always replaced by a jumper to simplify a circuit. If we have a circuit and we have to simplify it and we are going to replace a voltage source, then the voltage source is replaced by a wire. Next, we have the topic name is current source. A current source is a two-terminal circuit element that maintains a current through its terminals. The value of the current is the defining characteristic of the current source. Any current source is replaced by an open circuit, which simplify a circuit. It means that when we are going to replace the current source, we are going to short the circuit. The third one is a resistor. A resistor is a two-terminal circuit element that has a constant ratio of the voltage across its terminals to the current through its terminals. The value of the ratio of voltage to current is the defining characteristic of the resistor. The main function of resistor is to block current and maintain its value. The next topic is inductors. An inductor is a coil of wire through which electrons move and energy is stored in the resulting magnetic field. Inductors are simply coils of wire, can be air wound, can be wound around a permeable material that concentrates magnetic fields, can be wound around a circular form. Inductance is measured in henries. It means the henry is the unit of inductance. The last one is capacitors, a device that stores energy in electric field. The main function of capacitor is to store energy in an electric field. Next, two conductive plates separated by a non-conductive material. Think of a capacitor as very small temporary storage battery. The unit of capacitance is farads. Now, here we have our most favorite law, Ohm's law. Ohm's law state that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points and inversely proportional to the resistance between them. The mathematical equation that describes this relationship is V is equal to IR, means that voltage is directly proportional to current and also resistance. And next we have topic names Kirchhoff's current law. In short form, we write this as KCL. KCL states that the sum of current entering a node will be equal to the sum of current leaving the node. As in the circuit, we see we have a circuit having 12 volt source and 9 milliampere current. 9 milliampere IT is entering and the on other three terminals the current is leaving. and there is current of 4 milliampere, 3 milliampere and 2 milliampere. If we add all this current, it is equal to 9 milliampere, and which is equal to the total current. So here Kirchhoff current law is proved. Kirchhoff current law. Again here we have a different circuit. We have here we see that when the was in series, there is no change in the current, and when it is in parallel, the current may divide. Again we have another circuit. The total current here is 11 milliampere, and on one resistor it is 1 milliampere, and they said what is the current on the other side. So as we see that the two resistors are in parallel, so the current may divide. I total is equal to IR1 plus IR2. The total current is 11 milliampere, which is equal to 1 milliampere plus I2, and I2 we don't know. Here the equation come I2 is equal to 11 minus 1, and IR2 is equal to 10 milliampere. And here we get the answer. The IR2 is equal to 10 milliampere. Now moving to the next topic, named Kirchhoff's voltage law. In short form we write it as KVL. It deals with voltage. Kirchhoff's voltage law. It is also named as Kirchhoff's loop rule, is a result of electrostatic field being conservative. It states that the total voltage around a closed loop must be zero. Here the word is closed loop. It states that the total voltage around a closed loop must be equal to zero. So moving next, we see here an example and the definition of KCL, KVL. KVL states that the sum of the voltage drops around a closed loop will be equal to the applied voltage. So here we apply 12 volt, and there are three resistors in series. We find three voltages across three resistors. Across resistor 1 the voltage is 3 volt. Across second the voltage is 4, and across third resistor the voltage is 5, and the sum of these three is equal to 12 volt, and KCL is here proved. KVL can be used to solve for an unknown voltage drop. KCL can be used to solve for an unknown voltage drop. Here we have an example that here we have applied 10 voltage, and there is three resistors in series, and we know the voltages across two resistors, and we have to find the voltage across the third one. So here we know VR1, VR2 and VR total. So the equation comes is VR3 is equal to V total minus and minus the sum of VR1 and VR2, and the value of VR3 comes 5 volt. Here we have a brief discussion on Kirchhoff current law and Kirchhoff voltage law. Moving next, we are going to discuss Thevenin theorem. Through the use of the Thevenin theorem, we have the ability to reduce a complex circuit down to a simple series circuit. There are four steps here of Thevenin theorem. First one, remove the load. Second one, determine the voltage seen by the load. Third one is replace the voltage source with a short. Do not short out the power supply because there is a difference here between both processes. Determine the resistance seen by the load. Here we have a circuit. The step 1, remove the load resistance. Here in step 2, we are going to determine the voltage seen by the load, which is V Thevenin, and then replace the voltage source in step 3 with a short. Step 2, determine the voltage seen by load. Since R3 and R4 are not connected on one end, they do not carry current. Therefore, they cannot have a voltage drop. The voltage present between points P and A is the voltage drop across R2. Here, VR2 is equal to R2 over the sum of three resistors and then multiply it by V Thevenin or V total. VR2 is equal to 4 volt and VR2 is also equal to V Thevenin. So the value of V Thevenin is 4 volt. Moving next to step 4, determine the resistance seen by the load, means R Thevenin. R Thevenin is equal to R3 plus R1 plus R5 parallel with R2 plus R4, means R3 parallel in series with R4 and the sum of R1 plus R5 in parallel with R2. After putting the values in this equation, we got the value of R Thevenin, which is R Thevenin is equal to 8.4 kilo ohm. And here we have this Thevenin equivalent circuit. This is R Thevenin and this is V Thevenin. And here we again add the load and whatever, but it is the Thevenin equivalent circuit. Moving next to Norton's theorem. We also say that these both concepts are little bit opposite to each other, but it's a long discussion. So we are going to study Norton's theorem here by reducing all of the elements of a complex circuit to a single current source and a single source resistance which supply power to a load. A simple circuit can be created. Like here we have a current source I Norton with a resistor in parallel having resistance called as R Norton. Here also we have 4 steps. The first one is to remove the load. Second one, determine the current seen by the load. Third one, current short circuit the power supply, and the fourth step is determine the resistance seen by the load. So first of all, here we remove the load. In second step, we determine the current seen by the load. Here We replace the power supply with the jumper, and in the fourth step we find R Thevenin, and at last we have equivalent Norton circuit. I Norton with a resistor in parallel having value of 10 kilo ohm. So this is the end of this video, and I hope you may got the concept of electric circuit analysis, the basic concept. Thank you. Allah Hafiz. Allah Hafiz. Allah Hafiz.